Swayam Prabha. Digital India. Educated India.
So, hello everyone. So, we have reached the last part of the UV protective textiles. So, in last session we have discussed the effect of yarn twist, effect of yarn hollowness on UPF of cotton woven fabric, plain woven fabric we have developed. Now, here we are trying to take a different approaches. So, we are trying to create fabrics of different thicknesses, but trying to keep the cover factor same and same cover we are trying to keep, and also the linear density aerial density of the fabric will be same. So, same cover factor is basically the area covered by the yarn to the total area of fabric, that is the ratio. So, percent cover by warp yarn. So, if you see here, suppose this is the distance between the warp yarn, P is the distance between two warp yarns and the diameter. So, if it is d, so d by 2 in this side and this is the from the center, if you are taking d by 2 this side, total cover will be d, and d by p multiplied by 100, this is the percent cover by warp yarn or weft yarn. D is the diameter of yarn, P is the distance between two yarns. So, diameter of yarn, distance between the yarns, that is yarn spacing. See, if we know the yarn spacing and diameter, then we can control the cover factor. So, if we want to keep this d by p ratio same, so what we have to do? If we make the yarn finer, so d is reduced and the ratio, if percentage cover if you want to keep, so if for the finer yarn, so P has to be reduced. That means, if we make finer yarn, so we will make it keep it closer, so that the yarn spacing become closer, so that percentage cover remains same. And why do we want to change the diameter of yarn by changing the yarn count? Because the effective fabric thickness we want to change by not changing the fabric cover. So, if we reduce the yarn count, reduce the yarn diameter, that will be actually reduce the fabric thickness. Now, try to see here yarn diameter d and distance between the yarn is P here for finer yarn, and if you try to keep the yarn with a double diameter 2D diameter, here we must arrange the yarn with a distance double the distance, because effective spacing of the yarn should be kept constant. So, if we see this is there is a difference here, d minus p is the difference here, okay. And here it is a d, so 2 p, so p minus, sorry, it will be p minus d is the distance spacing. In this case spacing will be 2 p minus 2 d. So, here this will be d and here will be the. So, that is the spacing. So, fabric structure with different yarn diameter and spacing for the same cover factor. So, we can have, so if we keep the spacing here, so here p minus d, p minus d is the spacing, the space available here. So, if we see the cover factor here, the fabric cover will be d by p 100, and for coarser yarn this will be 2 d by 2 p. So, effectively the percent cover will be same. So, with this approach we have done the experimental, we have designed our experimental plan. So, 100% cotton yarn was used and 100% polyester. Two yarns were developed, 100% cotton and 100% polyester, and we have produced this yarn with 3 different counts. And 3 fabric sets both for cotton and polyester yarns, keeping their cover same, that we have produced the fabric. So, cover was kept same. So, depending on the yarn diameter, the peak density was changed, was manipulated to keep the cover same. The fractional cover formula is d 1 by p 1 plus d 2 by p 2 minus d 1 d 2 by p 1 p 2. So, d 1 by p 1 is a constant, okay. So, that we are trying to keep constant, and d 2 p 2 have been changed, okay, to keep the d 2 and p 2 same as d 1 p 1. So, that is there. So, diameter is changed by changing the cover factor to change the yarn linear density diameter. So, we want to change the thickness, but similar at the same time peak spacing was changed accordingly to keep this ratio constant. Now, here we have produced plain woven fabric from 100% cotton and polyester yarn. The work count was kept constant and weft count was changed. So, ends per inch was kept constant 50. So, for same warp set what we have done, we have changed the weft count to change the fabric thickness. Now, this table will give us idea about the ratio of yarn diameters. So, for polyester the yarn count 20, 30, 40 any, this is for warp. So, weft. So, for warp we have kept constant the 20s count, warp yarn we have used, end density 15, but for weft we have used 3 yarn count and corresponding diameter we have measured 0.235, 0.201 for 30 is any and for 40 is any 0.166. So, yarn diameter gradually reduces with the increase in English count, that is yarn, as yarn becomes finer, yarn diameter reduces, and with reference to 20 NE the diameter ratio was measured. So, the 30s yarn as compared to 20s yarn is diameter ratio is lower by 1.17 times. So, that means 20s yarn is 1.17 times thicker than 30s yarn and 1.41 times thicker than 40s yarn. So, this is the diameter ratio. Now, for peak density, to keep the same D by P ratio, we have to adjust the peak density accordingly. Now, try to see here. Here weft count 20, 30, 40 and set 1, set 2, set 3 we want to get a particular cover factor. So, set 1 is loose structure with less cover factor, set 2 is a little bit more cover factor and set 3 is little bit higher cover factor. Now, how this 40, 47 and 56 was decided? These peak densities were decided just to keep the cover factor same of all 3 fabrics, serial 1, 2, 3. So, in this all these 3 fabrics we should keep cover factor same. Similarly, set 2 will have higher cover factor, but all in between these 3 fabrics the cover factors will be same. So, 1, 2, 3 serial number, the cover factors will be exactly same. Similarly, for set 3, how is it selected? So, based on this diameter ratio, so as we have calculated the diameter ratio here for 20s and 30s, diameter ratio is 1.17. To keep the this cover factor same between 20s yarn and 30s yarn. So, we have to increase the peak density from 40 to 47 and which is nothing but the ratio, this ratio. So, 47 by 40, this ratio is as per the ratio of the yarn diameter. So, 40 to 47 is with this ratio and 47 to 56 is with the ratio of 1.41. So, similar ratios were kept for set 2 and set 3. So, for all these 3 fabrics series 1, serial 2, serial 3, for same set the cover factor will remain same. This was for polyester. Similar experimental plan was made for cotton. Here 20s, 25 and 30 yarns were produced. Earlier in case of polyester it was 20s, 30s and 40s. Here 20 NE, 25 NE and 30 NE, and as the yarn becomes finer their diameter reduces 0.255 millimeter, 0.212, and for 30s count the diameter is 0.187, and their diameter ratio as compared to the 20s count, for 30 count the 25 count it is 1.20 and for 30s count it is 1.36 diameter ratio. And similarly, as like polyester fabric, we have adjusted the peak density. So, this is the peak density here between 20s and 30s. So, 40 and 48 the ratio. So, if you adjust the ratio 48 by 40, it will become 1.2. So, we have kept this the ratio same, and between 40 and 54 the ratio is 1.36. So, similar ratio was kept for set 2 and set 3. So, set 1 is the little bit open structure, set 2 is closer structure and this is closest structure. So, with higher cover factor. Now, try to understand the results. So, cover of polyester fabric. We can see with the set 1 relatively open structure. So, the cover factor is around say 77 or like that. So, that cover factor, and with the yarn count this cover factor does not change, it is not significantly different because we try to keep the cover factor same. So, these are almost same, there is no change in fact. The cover factor with the count because we have adjusted the peak density. So, the cover factors we can consider are almost same for a particular set, but overall cover factor increases with the set because the set 3 is the more compact structure with higher cover factor. So, set 1 is the least covered fabric with open structure. Now, let us try to understand the thickness. So, our target was to reduce the thickness. So, we have changed the yarn count here for a set. We are keeping the cover factor around 78%. So, this set is giving 78% cover percent average cover factor. For 78% cover factor, we can see that the thickness is consistently reducing The same trend is true for other set. For set 2 with a cover factor 84%, average cover factors overall, the thickness reduces. Similarly, for set 3 with 89% cover factor so thickness reduces consistently with the increase in count. That was our idea. So, now what we are trying to study, what is the effect of thickness on UPF value keeping the fabric cover factor same. Now, if we see the aerial density we are keeping the cover factor same, not the aerial density. So, aerial density is reduced with the increase in yarn count. So, as yarn becomes finer, aerial density reduces. So, the thing is that here as yarn become finer, the cover factor remains same, or percent cover remains same, yarn thickness reduces and it drops, and the yarn fabric weight drops. So, that was our observation. Now, try to understand the UPF value, UPF of fabric without UV finish treatment. The UPF, here we can see the UPF without treatment, it is as the content, fiber content reduces, because fabric aerial density reduces and thickness reduces, normal trend it is reducing, okay, with the reduction in that as yarn become finer. And after UPF, after UV finish, so it is without UV finish, where there is a chance of the UV ray to pass through the yarn structure. So, in that case the trend is it is reducing, and even for the finer yarn it is much lower also than the coarse yarn. This is the coarse yarn. And after finish we will see the trend has changed, because as the yarn becomes finer. So, this is the coarser yarn, 20 count, 30 count, and this is 40 count. This is 40 count. As the yarn becomes finer, initially the UPF drops, then after that the UPF increases. This is actually visible for all the different set, fabric set, cover, but for higher cover this phenomena is more prominent. So, UPF decreases at first, then increases with the decreasing fabric thickness. So, fabric thickness reduces. So, UPF initially decreases, then it is increasing, but for without finishing, as the fabric thickness decreases, the UPF decreases, also here the areal density also decreases. But interesting thing is that here this increase is the interesting thing. So, UPF value is increased after initial decrease. The trend in UPF with the changing fabric thickness is different for untreated and UV treated fabric. So, untreated fabric, the change is consistently reducing with the decrease in fabric thickness, but here it initially decreases then increasing. So, in case of earlier without treatment fabric, UPF reduces continuously, whereas for treated it increases and then the increase with the decrease in fabric thickness, that is the trend. Now, this trend we try to analyze in detail, what is the actual reason for this type of phenomena. So, detailed investigation was carried out. So, UPF of polyester fabric before and after treatment is that the area of individual pore reduces and the number of pores increases when the finer weft was used with higher peak density. So, what to keep the pore volume constant, that is our the pore total pore area constant, that is to cover percent constant. So, for finer yarn we have kept higher peak density, okay, and with proportion to the yarn diameter. So, this is actually tantamount with the breaking of big pores. So, one big pore was divided into small pores, keeping the same pore area, okay, large big pores into a large number of small pores. So, overall pore area we are trying to keep constant. So, the UV ray should effectively pass through, the same quantity of UV ray should effectively pass through, but that is not the case, because in case of larger pore, when the yarn becomes little bit flattened, the impact, flattening impact is not that great in case of larger pore, but in the smaller pore, large number of pore, the smaller pore. So, flattening impact will be much more, okay, and the smaller pores have probability to be covered by the yarn flattening, and also the yarn hairiness are there. Here the smaller pores will be easily covered by the flattening and yarn hairiness here. So, that is why this impact is there, okay, and this is actually more prominent in case of the closer fabric, that is higher cover factor. Higher cover factor, that means even individual pores are much smaller. this effect is more prominent for higher cover and also magnifies if UV absorber material is used. So, when we are using the treated UV absorber treated fabric, in that case this impact will be magnified. Now, see the pore characteristics here. So, individual pores, so coarse weft with lower peak density. So, there two peaks are there and finer weft with higher peak density. Here we are making it 3 pores. So, here if in this picture you can see effectively we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pores are there. And in that 9 pores are actually subdivided into 4, 5, 6, 7, 8, 9, 10, 11, 12 pores. So, if these are the partial pores. So, if you see the complete pores, only 3 pores have been divided into 6 smaller pores, individual pores are there. Let us see the fabric structure here. So, fabric cover for fabric set 3, so 89% coverage is there with the 20s count. See 20s count, coarser count with 60 peaks per inch. Here number of pores are larger and smaller, smaller number and larger size. For 30s count, where we use the higher peak density, the pore size has reduced, but number of pores have been increased. Okay. Now, fabric of set 1 78% cover, we can see the pore size is higher, here the pore size is lower and it is further reduced. Now, here one should see very carefully the effect of the yarn hairiness blocking is more in case of the closer weave. So, higher, that is more closer yarn for same cover factor, but when the this distance between the weft yarns are smaller, in that case the chances of covering by the hairiness is more, and due to the effect of the flattening of yarn will be more prominent here. And same result, similar result for fabric set 2. So, overall effects of fabric thickness and pore size are like coarser weft with lower peak density. So, finer weft with higher peak density. So, from coarser weft with lower peak density to finer weft with higher peak density, if we move, then what happens here? The thickness reduces, UPF reduces, and cover factor remains same. So, UPF should be same, but when pore size is reducing, individual pore size is reducing, the UPF should increase. So, all these 3 effects are coming together. Now, try to see the cover of cotton. Till now what we discussed was cover percent of polyester, now cover percent of cotton fabric. this is the cover percent is almost same, there is no significant difference is there. Thickness is reducing consistently with the change in the yarn count. Thickness is reducing. Here the cover factor is 88%, 93% and 96% cover factor. The areal density is showing the same trend. Areal density reduces with the as the yarn becomes finer. So, 20, 30, 25 and 30 yarn becomes finer, the areal density reduces. So, UPF value here, the UPF value for the effect of this yarn count is not that prominent, it is not that clear here, but as the fabric cover increases from set 1 to set 3, 88%, 93% and 96%, the UPF generally increases, but there is no significant impact of yarn count or maybe pore size on UPF of cotton fabric. This is for untreated, and for UV treated fabric, this trend we can see here. The UPF value initially at low set, initially it dropped and then increasing, but at higher cover factor, interestingly, which is different from polyester, here it is consistently increasing from the coarser yarn to finer yarn, because pore size here is for coarser yarn with the larger pore and lower number of pores, the UPF is less, but for finer yarn with the lower number of that smaller size of pores, but larger number. In that case, this type of smaller pores with a larger number, in that case the UPF becomes very high for treated. This trend is different from the polyester. So, the reasons here, the effect of thickness and individual pore size here opposing each other. So, thickness is reducing, but individual pore size is also reducing, they are opposing each other. So, as far as the thickness reduction is concerned, the UPF should be reduced, but the pore size is also at the same time gradually reducing. So, at lower level of cover like 88% cover, the effect of thickness is dominating over the pore size. So, there we will get some drop in UPF value as the yarn becomes finer. However, if the pore size reduction reduces beyond critical value, like here pore size reduction is crossing the critical value, it has more dominating effect than the thickness in determining the UPF. So, here we will see the pore size is more dominating than the thickness here, particularly for UV finished case. So, in set 1 we will see that mean pore area is reducing. The mean pore area from 20 to 30 count. So, peak density is changed and cover area is kept almost constant, but mean pore area is reduced. So, number of pores are increased, but mean pore area has reduced. In case of higher set, that is compact fabric, set 3, mean pore areas are very small, okay. And in this case set 3 compact fabric, the impact is very high, pore size is reduced. So, the UPF value increases with a significantly. So, what should we conclude here? So, overall study or basic conclusion is there is no significant effect of yarn twist on cotton woven fabric for its UPF characteristics, okay, and this is within the experimental zone. So, beyond that zone or if we do the other study, that there we may get different result, but within our study we have observed this trend for 100% polyester UPF of fabric decreases with the decreasing thicknesses. So, 100% polyester fabric. So, as the thickness decreases, UPF also decreases when the fabric cover is kept same. So, thickness has got its effect. However, after UV finish, the UPF decreases and then increases. So, that we have already discussed. And cotton fabric does not have that effect of decreasing thickness on the UPF, okay, at constant cover factor, but as the cover factor increases, the UPF increases. But after UV finish treatment, which is important, the cotton fabrics UP shows similar trend like polyester at 88% cover factor. However, UPF increases continuously with decreasing thickness at highest level of cover. So, these are the different trends we have observed, because only the thickness does not matter, fabric flattening and the breaking of the larger pore to smaller pores, fabric hairiness also comes into picture. So, there are different complex phenomena are happening together. For the same fabric cover, the individual pore size of the fabric plays a critical role in determining the UPF along with the fabric thickness. So, individual pore dimension plays a very important role. So, fabric thickness is okay, but the individual pore size plays a role that as we have discussed. So, a larger pore and smaller pores. So, smaller pores will be affected by easily by the flattening of threads or easily be blocked by the hairs. So, that is how this trend happens. And for cotton has actually short fibers, it creates a more hairiness. So, for closer and compact fabric and with a closer smaller size of pores. So, this effect of hairiness is prominent, that is why it continuously increases the UPF value. Besides, there are interactive effects of pore size, fabric thickness and fabric cover and UV protection capability of the material which determines the UPF. So, UV protection capability of particular material also, like polyester has higher UPF than cotton. So, we have to engineer the fabric depending on all the keeping all these things into consideration. So, at low level of cover with unfinished material, thickness has prominent effect over pore size in determining the UPF. So, at low cover, so thickness we can if we change the thickness, if we reduce the thickness, then the UPF will reduce consistently. But at higher cover factor with UV finish, this trend is reversed, as we have seen in case of cotton. In case of cotton, with the decrease in thickness, the UPF value and decrease in thickness, and after UV finish the UPF value increases. So, we will stop the session of protecting ourselves, protective clothing for UV protection, and we are closing this session and we will start with a new session next time. Thank you.